Section 3.5 is about showing lines are parallel. So suppose two lines are cut by a transversal and a pair of corresponding angles is congruent. Are the two lines parallel? Well, the converse of an if-then statement is the statement formed by switching the hypothesis and conclusion. So all we did was we switched the left side and the right side. So if you live in Sacramento, then you live in California. So the converse is, if you live in California, then you live in Sacramento. Well, sometimes the converse is true, sometimes it's not when you switch them. So for instance, this converse is not true. If you live in California, then you live in Sacramento. No, because I could live in LA. So that would be a counter example showing the converse is not true. Remember, we're trying to decide, okay, so last time we learned if two lines are parallel, then the corresponding angles are congruent. So because the corresponding angles are congruent, does that mean that the lines are parallel, right? We're switching the order. Because before we said, okay, if parallel, then corresponding angles were congruent. Can we switch them around and say, okay, because the corresponding angles are congruent, that means they're parallel? That's the big question we're trying to answer. So write the converse of the true statement. If two segments are congruent, then they have the same length. And determine if the converse is true. All right, so we can say, if two segments have the same length, then they are congruent. Right, and then that will be true. That's true, right? If they have the same length, then they will be congruent. If they're congruent, they have the same length. The converse is true. So we can say true. All right, let's give it a shot. So if angles 3 and 4 are complementary, then measure of angle 3 plus measure of angle 4 is 90. Okay, let's flip it around. We can say if the measure of angle 3 plus the measure of angle 4 is 90. So if measure of angle 3 plus the measure of angle 4 is equal to 90, then angle 3 and angle 4 are complementary. That is 100% true. Complementary, because being complementary just means they add to 90. And if something's complementary, that means, oh, they will add to 90. So that's fine. Okay, let's try the next one. If angle 1 and angle 2 are right angles, then angle 1 is congruent to angle 2. Okay, so switch it around. We can say if angle 1 is congruent to angle 2, then angle 1 and angle 2 are right angles. So is the converse true? No, it's going to be false. This is not false. Just because two angles are congruent doesn't necessarily mean that they must be 90 degrees. So for instance, the measure of angle 1 was 5 degrees and the measure of angle 2 was 5 degrees. That means that, oh, you know, the angles are congruent. Angle 1 is congruent to angle 2. But those are not 90 degrees. So this I just did was a counter example. I showed that the converse was false. Now, for the first two examples, like I discussed, like, oh, they're true. I can't think of anything that would prove them not true. So, converses of previous postulates and theorems. Whew, lots of stuff to go through. So, postulate 9, corresponding angles postulate. If two lines in a plane are cut by a transversal such that the corresponding angles are congruent, then the lines are parallel. So the abbreviation is corresponding angles are congruent, therefore they're parallel lines. So here we can say if angle 1 is congruent to angle 5, then L and M are parallel to each other. So this is when we're proving the two lines parallel. So we weren't given that they're parallel, but if we knew that those two angles were congruent, then we could conclude that those two lines must be parallel. Okay. Theorem 3.8, alternate interior angles converse. If two lines are cut by a transversal, so the pair of alternate interior angles are congruent. So if we have a pair of alternate interior angles that are congruent, therefore that must mean these two lines are parallel. So if angle 3 is congruent to angle 6, then line L must be parallel to line M. Okay, so I picked one pair of alternate interior. If you could have said, you know, angle 4 and angle 5. Up here, oh, there's 4 pairs of corresponding angles instead of angle 1 and 5. Right, other options up here would include angle 2 and angle 8. Sorry, where does angle 6 go? I was looking at the wrong guy. Angle 6, angle 3 is congruent to angle 7, angle 8 is congruent to angle 4. Right, any of these options could have went in there. Same way here, I could have chose angle 4 and angle 5 to go in here. All right, alternate exterior angles converse. So if two lines are cut by a transversal, so a pair of alternate exterior angles are congruent, then the two lines must be parallel. So the abbreviation, alternate exterior angles parallel, so parallel lines. Sorry, alternate exterior angles congruent, so parallel lines. So I can say if angle 2 is congruent to angle 7, then line L and M must be parallel. I can also say, you know, angle 1 is congruent to angle 8 because those are another pair of alternate exterior angles. Uh-oh. Come back up here. All right, same side interior. If two lines are cut by a transversal, so that the same side interior angles are supplementary, so these two angles are supplementary, meaning they add to 180, then I know that these two lines must be parallel. So if the measure of angle 3 plus the measure of angle 5 is equal to 180, because that's what it means to be supplementary, then line L and M must be parallel. I also could say the measure of angle 4 plus the measure of angle 6 is 180. That's just the other side. That's the other pair of same side interior angles. All right, determine whether each diagram gives enough information to conclude the lines are parallel, and then explain. So here, I have 110 degrees here, 110. So yes, there is enough information to conclude. And the reason is because corresponding angles are congruent. Corresponding angles are congruent. And we know if corresponding angles are congruent, then the two lines must be parallel. All right, let's see. We're only given the fact that these two angles are congruent. Yes, there's enough reason. It's because the alternate interior angles are congruent. Alternate interior angles. Because those two angles are congruent, therefore we can conclude that these two lines must be parallel. Right? We can conclude these two lines must be parallel. All right, let's check it. Is there enough information? Well, let's see. You know, right here, I could have a linear pair, which means that if I go all the way across, it would be 180 degrees. So this angle here must be 80 degrees. Okay, so linear pair. That means this angle here must be 80 degrees. And wait, this angle and this angle are the same, and those are corresponding angles. We have enough information. Yay! So, because we know corresponding angles are congruent. So because the corresponding angles are congruent, we can conclude that the lines must be parallel. So just drawing those little like parallel symbols. All right, do we have enough information to conclude that they are congruent? We have nothing over here. No measures, nothing. All we're given is this one angle. What the heck? What the heck? Not enough info. Not enough info. This sucks. We don't have enough information. We have nothing over that second intersection. All right, let's review compound inequalities one more time. Okay, so we have to get the x by itself, divide by 3, and we have x is less than 2. Okay, so over here, let's add 7 to both sides. 2x is greater than or equal to 12. Divide by 2. So we have an or, right? Don't forget we have that or in the middle. So x is less than 2 or x is greater than or equal to 6. So this would be the solution to inequality, and now we must graph it. So at 2, I have an open circle and the arrow goes this way. and at 6 I have a filled circle, and the arrow goes the other way. That would be the solution. And then because it's written this way, this must be an and because it's between two numbers. So I can say x is greater than or equal to -2/5 and x is less than or equal to 0. So let's see, -2/5 is about here. I gotta zoom in a little bit. Okay, so -2/5, it's about like here. So I have an open circle, nope, closed circle, and then 0's here. So I have this small segment right there. That's it. That's the whole thing. Very, very small segment because it's or equal to on both sides. All right, we're getting close. Last page. So find the value of x. So v is parallel to w. Okay, we want them to be parallel. I want these two to be parallel. So based on what I'm given same side interior angles. Well, that means that, okay, same side interior, they have to equal 180 in order for them, in order to be supplementary, they have to equal 180, and if they are supplementary, that would prove that line V is parallel to W. So I have to find the value of x where this is true. All right, we have same side interior equals 180. That would be enough to prove it. So I set 70 plus 2x equals 180. Subtract 70 from both sides. 2x equals 110. Divide by 2 and we get x is 55. All right, we're trying to find the value so that way it would be true. Here we have alternate interior angles, right? These are alternate interior angles. And so in order for these two lines to be parallel, the alternate interior angles should be congruent. They should have the same measure. So I set them equal to one another, and I get x is 10. Part B. Oh, what the heck? I have two B's. That's awkward. Okay. So we want this to be true. We have, we can call them consecutive interior, same side interior. That means the same thing. All right. These are consecutive, aka same side interior. All right, and so they should equal 180 degrees. So if I add them together, they should equal 180. So x is equal to 30. Because I combine like terms, divide by 6, etc., etc. All right. Here, once again, it's the same thing, right? These are consecutive interior, same side interior. These two angles must add to 180 degrees, right? In this little box, that's 90. So I know 90 plus x plus 22 is 180 degrees. So I have x plus 112 is 180. Subtract 112 from both sides, and we get 68. All right, match the theorem postulate to use to explain why P and Q are parallel in the diagram. So let's look at A. All right, we have alternate interior angles. Because they are congruent, we can say P and Q are parallel. So what did we use? The alternate interior angles converse, because normally it says, oh hey, if you have two parallel lines, then the alternate interior angles will be congruent. We flipped it, so we're using the converse. If the two alternate interior angles are congruent, therefore the lines must be parallel. Let's look here. We have corresponding angles. So this is the corresponding angles converse. And then lastly, that leaves us with the same side interior angles converse. Since these add to 180 degrees, I know that they're supplementary. Therefore, that only happens if they are part of two parallel lines. All right, right? If then statement is converse, so both statements are true. There's many, many examples, so you guys can think of them and look at the ones we did in class.